Guys, today is Tuesday, March 17th. Happy St. Patrick's Day. So I hope you all had a chance to look at the Law of Sines on Monday. Law of Sines is a way for us to continue to work on triangles with trigonometry. But as we saw yesterday, it only works for certain types of triangles: angle, angle, side, angle, and so we said we'd work on the ASS one today. So today we get to see what's going on with that donkey triangle. So let's take a look at that and see. Hopefully you have your calculators ready to go. Once again, feel free to copy down the notes, stop the video, and keep playing it as we go along. So a couple of background things. If you remember back in geometry, there were 5 ways to prove triangles congruent, and ASS was not one of them. So today we take a look at why we can't use ASS as a congruence theorem. Another question from our trigonometry past: in what quadrant is sine positive? Since you all have to take calculus, in other words, all students take calculus, you all should know that it's positive in quadrant 1 and quadrant 2. So you can see my lining up is not very good. So we got quadrants 1 and 2. That's where things are positive for the trigonometric value of sine. And then supplement. Supplement is when 2 angle measures add up to be 180 degrees. So here, we'll try to aim a little bit better. 180 minus 72 is going to be, anyone? Yes, very good, person in the back, 108 degrees. So that information is going to be kind of important to what we're going to be doing today. Supplements, quadrants, and the fact that the angle side triangle is not a way to prove triangles congruent. So let's take a look at a angle side problem. The issue with an angle side problem is that there is possibility of more than one triangle existing with the given information. And so in order to check this out to see if it has more than one triangle, it may help you to understand or to put the information on a triangle. So we'll just throw a triangle down here real quick. And let's see, so if this angle measure here is 16, and that's angle B, then our 30 is going to come on this side of the triangle, and the 34 can really go on either side, any other side you want. So we'll just put it over here. And notice that that is an angle side configuration of a triangle. So whenever we have an angle side configuration, we've got to check for both options. So down here is a little chart to kind of help you keep yourself organized. I've got some directions going on over here to the right, and as long as you can follow that along with knowing how to do law of sines, then we should be okay. This is a whole lot easier than using an uncalibrated smartboard. All right, so let's put our information on our law of sines proportion over here. All right, so we'll put A, 34 on the top. We'll put B, 30 over here. Come on, there we go. And we've got angle B, so that's going to end up over here. Sine of 16. It's going to be on the bottom of 30 degrees. Sorry, 30. Remember that angle B and side B will be on top of each other as a fraction. So over here on the bottom of 34, since this is side A, we'll use the sine of A. So first step is we find angle A using the law of sines. So I trust that you know how to solve that. So we will go ahead and calculate that, and I'm going to put the answer right up. So go ahead and calculate, and I'll pop it up. So after making calculation, angle A is 18.2 degrees. Okay, so we take that 18.2 right here. It says find angle A, so we did that. And we're going to come down here, we're going to write it in both, I'm sorry, we're going to write it right here in option 1. So that's going to go 18, I'll tell you what, let's try that differently. Let's write that down. Nope, I like it better the first way. So 18.2. We'll color that so we know that it's been calculated. Next color, boom. There we go, 18.2. Second step, okay, we're going to find the supplement to A. So the supplement of A is 180 minus 18.2. That gives us 180 minus 18.2. It's going to give us 161.8. So that goes right here, 161.8. Okay. So we now have, this is basically going to be triangle A. This is going to be like the first option, and this is going to be our second option. So remember, with a angle side triangle, there's an option to have a second version of the triangle. And so our goal, our job, is to be able to find both of those triangles if they exist. So as we continue on here with step 3, we're going to try to find angle C. And so yesterday, hopefully you remember the triangle sum theorem, that we can take, I'll write it down here on the bottom, 180. I'm going to use a different color. Let's use purple. 180 minus 18.2 minus 16 is going to give us the angle measure that's going to go right below 16. So this is going to be angle C. So 180 minus 18.2 minus 16 is 145.8. So that's coming up here. 145, that didn't work. Into the cell, there it is, 145.8. Purple. Okay, so that's that calculation. I'm going to slide this over a little bit. So we definitely know we have one triangle because we have 3 angle measures. So we'll move over. We'll do that one more time, and we're about to find out if we have a second version of a triangle. I'll do that right here in a different color. 180. Oh, that didn't work out. 180 minus 161.8 minus the 16. We'll see what that gives us. And if it gives us a positive value, then we have a second triangle. 180 minus 161.8 minus 16 is 2.2. So it's a very small angle, but it does exist. So we'll come in here, 2.2. We'll give it a color of blue to kind of give you an idea where that calculation came from. And so since all angles are positive angles, we answer the question, do both options make legal triangles? And the answer is, drum roll, yes. Yes. Okay, So then we have to use our law of sines to find little c for both triangles. So essentially what you've done is you have answered 5 pieces of information and you need a 6th. So I'll try to show you basically what that basically looking like. All right, so down here, whoops, go far enough right here. We'll add a little bit more to that. Give me a segment. Okay, so this is going to be the first option. The second option is going to be over here. So it's a lot of work to find the second option. That's why we save this for its own day. All right, so we now have 2 law of sines setups. And these are the angles that you have. Okay, so option 1 over here is sine 18.2 sine 16, make it smaller, and sine 145.8. Side lengths are given to you up top in the original problem. A is 34, B is 30, and that's going to stay constant for both triangles. So you have a 34 here, and you have a 30 here. That's constant for both triangles. So 34, 30. So on the first option, you got to find your little c. Got to find a little c over here too. But on the second option, you have different angle measures. So here, on the second option, you bring your angle measures in. Sine 161.8. Sine 16. And sine 2.2. We'll make that smaller for you. And here you use, you could use almost any combinations that you wanted. We'll just use a pen. Get some red going here. So since we want to find side C, you use the second and third fraction on each calculation. I'm going to calculate those real quick. Once you start multiplying that, I'll be ready. So on this one, on the first option, little c is going to be 61.2. And please note, when we have that, 145 degrees is the largest angle, so naturally side C would be the largest side on this triangle. As we move over here to the right, the second option, the 2.2 angle measure is very, very small, so that should tell you that letter C is going to be a very small angle. I'm going to go calculate that. I'll be right back. And in comparison to 34 and 30, this little c will be 4.2. So that is in an entirety a law of sines angle side problem. So I'm going to show you a couple other options. Won't quite take quite as long because I'm not going to do the entire calculation, but I'll show you a couple different things that can happen here with an angle side-to-side ambiguous case problem. So here we have another setup. We have sine 153 degrees. That's going to be angle B. Side A is 16. Side B is 38. We'll put a sine of A over here. I don't know why I've got this as B, because it's not. We have to go find angle A using law of sines, like we had just done in the previous problem. After calculation, we find that angle A, sorry, capital letter, is 11.0 degrees. All right, so come down here, we have 11.0 degrees. So this problem is going to be different, remember, otherwise I wouldn't be showing it to you. So over here, we do its supplement. So 180, minus 11 is going to give us 169 degrees. So that's a pretty big angle. 169 degrees. Now, hoping you can start to see what our problem is. All right, so we found angle A using law of sines. We found the supplement of A, which is going to give us the angle 2 option, right here. Now, our third step is to use triangle sum theorem to find both angle C's. And if you watch carefully, you'll notice that one of these is going to not work. So if we do 180 minus 11 minus 153, that gives us a good positive answer. That gives us a 16. We get over here to the second option, 180 minus 169 minus 153 is going to give us a negative 142 degrees. Well, that's a problem because that angle doesn't exist. So when we look at answering the question, do both options make legal triangles? Well, no, they don't. This second option over here came out to be a negative value. So we really only have this one triangle that we would have to go and find little c for. And it ends up being the only other piece of information you need to solve this problem. So then you would go into, you set up your law of sines, and you only have these angles to deal with. So you've got sine of 11, sine of 153, and sine of 16. Your angle measures, your side lengths up top, you have little a and little b. So you have 16 that goes on top here. 16, and I don't remember the third one. 38. So then you have to find your little c, and that ends up being the only other thing you have to do for this problem. There's only one answer. Only one triangle exists in this question. So you'd have to go and finish up little c in order to finish this problem. All right, I want to show you one more thing before I get out of here. This is a law of sines ambiguous case, as it says here on Delta Math. It says find all answers that are possible. So as we do this problem, you go through. So you go through and just start the problem as normal, right? So we'll use the little proportion I have going on down here. Let's see, we have L and M. So we'll put a 99 here, put a 17 there, and the angle is M, so it's going to go under the 17. So sine of 165. All right, so over here, you got sine of n. Now, as you continue to try to do this calculation, here is what it looks like in the calculator. So we do 99 times sine 165, you divide by 17, you get 1.5, and you continue to try to do the math in the calculator, and you get an error. Well, that's because sine can't be bigger than 1. If you remember your unit circle, unit means that the radius is 1. So the sine can't have a value that's greater than 1. So in this case, there's no answer at all. The very first thing you try to do, it doesn't work. So remember, this is a delta math question. So then the question becomes, how do I answer this delta math question if there's no answer at all for the problem? Well, I went and checked that out for you. So if you actually leave the answer blank and just hit the submit button, you get the empty brackets right here. If you hit yes, you get a nice big green check mark and it's correct. So in the case that you have no answer at all, don't put an answer in the blank. Just hit the submit button and then hit yes, and it'll work out for you. All right, good luck. I only had a few people asking me questions today or on Monday, so I look forward to talking with you guys on Tuesday. Have a great day.